The speaker we have this evening, we have courtesy of Larry Smarr. I'll make a couple of comments about Ram's background, and then I want to talk a little bit about him personally. Ram is the Distinguished Professor of Climate Sciences at the Scripps Institute of Oceanography, UCSD. You may remember him because he discovered the greenhouse effect of CFCs back when we were all a little bit younger, and the effect on the ozone. He correctly forecasted then, in 1980, that the global warming due to carbon dioxide would be detectable in the year 2000. He led the Indian Ocean experiment that discovered the widespread South Asian atmospheric brown clouds, or ABCs. He now chairs the UNEP-sponsored ABC project. He also chaired the National Academy of Sciences report in 2009 called for a major restructuring of the U.S. climate change science program. He is the recipient of numerous awards, including the American Meteorological Society Rossby Medal, the Royal Dutch Academy's Buys Ballot Medal, the Volvo Environment Prize, the Zayed International Prize for Environment, and he is the co-recipient of the 2009 Tyler Prize for Environment, considered to be the top environment prize in America. Since its inception, Ram has been a member of the Intergovernmental Panel on Climate Change, the IPCC, which won the Nobel Peace Prize in 2007. He has been elected to the American Philosophical Society, the U.S. National Academy of Sciences, the Pontifical Academy of Sciences by Pope John Paul II, and the Royal Swedish Academy of Sciences. And now, of course, he's the opening night speaker at FiRe. When Larry mentioned that Ram might be available, I will confess that I didn't yet know about Ram. And within moments, he had appeared on the front page of the New York Times business section, and then won the Tyler Award about a week later. It was like everywhere I turned, here's this guy. And it was obvious to me, although it's one of those kind of, you spend 30 or 40 years on something which becomes an overnight success, that we had been well served again by Larry Smarr, and that we had luckily picked somebody who is probably the person on the planet who best understands the connection between human beings and our climate environment. So with no further ado, I would like to introduce Ram.
Thank you, Mr. Anderson. It's a great honor and pleasure to be here. I know it's 8:15, 8:30, late in the night. You probably will most likely forget everything I say tonight. So I want to start off with one or two messages which I'd like you to remember. The first thing is that, my work is on climate change, and particularly global warming. So I'll give you my sort of opinion. I'll go to scientific facts later. Basically, I think as far as the climate change problem is concerned, we are long past for meetings, for dinner talks, and for academic discussions of the problem. I think the time is now for action. And that's the primary reason I invariably don't go to meetings which are purely academic, and although that's my passion. So when Professor Larry Smarr generously invited me to this podium, I gratefully accepted, because a quick search of this impressive meeting, which is organized by Mr. Anderson, that I get the impression this is the group which wants action. So hopefully I'll have something towards that goal. So the first message I want to give is just, I put it there. Basically, we have put enough of these greenhouse gases to do sufficient damage to the climate system that we would soon, when I say soon, a few decades, decade, or definitely by the middle of this century, it would be a different planet. And I'll sort of tell you what those differences are. And so the first half of my talk, I want to walk you through the science which I've done over the last 35 years, which led me to this depressing conclusion. And about 4 years ago, 4.5 years ago, before I was going to hit 60, the magic 60, I felt quite disappointed with myself and kind of upset that I have come up with nothing but bad news for the planet. So I thought it's time for me to start working on the solutions. So I'll spend the first half of my talk pointing out that we have got ourselves into a hole. And the second half, hopefully, will try to point out to you how to get out of that hole. But right off the bat, I want to mention that the actions contemplated, both on the international domain and in the US domain, while they are all the right steps, they are not enough. Okay? So we have to think about the problem slightly in a different context, and that's the context I want to place to you. So let me start with first, I look at this, every time I look at this image, I get a different view. First I'm showing this image. This was taken in 2007. The blue line you see off of Japan is when I was on a Gulf aircraft. This was a Gulf Fire research aircraft. I was following a pollution and dust plume off of China all the way across the Pacific. And we had to stop that plane in Hawaii and then pick it back up. And then we followed this pollution and dust plume all the way into Colorado. Okay? And what's interesting is that when we go outside, the atmosphere looks so vast. Your first impression is, we're not going to be able to do anything to this. It's so huge. The planet is resilient. The atmosphere is huge. But look at the thin shell. That's what the atmosphere is. It's a thin, fragile shell. And it's in that thin layer we are dumping billions and billions of tons of pollutants. So what are the source of those pollutants? Of course, you see smokestacks. And I want to make right off the bat a distinction. What you see as pollution is particulates. They are not greenhouse gases. And I'll talk about those too. They are pollution, okay? But along with what you see as smokestack comes these billions of tons of greenhouse gases. Carbon dioxide is one of them. And then the second on the right, you see automobiles, a major source of both pollution, air pollution and greenhouse pollution. But they're not the only two ones. There's biomass burning of forests, clearing of land for habitation, etc., is a major source. And the reason is simple. No matter what you take, gasoline or tree or paper, it's all hydrocarbons. So when you burn things, the carbon combines with oxygen and goes into carbon dioxide. Okay? That's a greenhouse gas. And the next is my village, and paddy cultivation is a major source of one of the important greenhouse gas. We call it methane. And the last one you see is my grandmother's kitchen. I've sat on that floor and enjoyed the most delicious meals. Even when I compare with the fantastic sea bass I heard, I still think my grandmother's cooking was the best. So I want to ask a question. Why should you worry about what my grandmother is cooking with? That picture you see here where a dish is being cooked with firewood was not taken 50 years ago when I was there. I took that picture 3 years ago. It's still happening. Of course, she's not here. I'm sure she's watching me down, picking on her. So why should you worry about what she cooked with? Likewise, why should she worry about what car you and I are driving here? I would like you to watch the next movie very carefully. It shows how fast the atmosphere moves around the planet and takes everything around. And the clock is ticking on the bottom, okay? And if you follow off of China, like I did that with the Gulf aircraft, in a matter of somewhere between 3 to 5 days, depending on the season, all the pollution emitted in the East Asia travels across into the US, okay? So while our Chinese neighbors are giving their gift to us, if you move your eye to the right, you see that we pass along our gift to our Europeans. I had a distinguished Swedish colleague. I just want to tell him, in a matter of 3 days, you're smelling what we emit here, okay? So while that's happening, the Europeans are sending their gift on to Asia, again, in a matter of 2 to 3 days. That's how fast atmosphere travels. And the other disturbing thing is if you focus on South America or Australia, you can see how fast biomass burning in South America, the Amazon region, or industrial pollution from Australia, or savanna burning from Africa goes into the Antarctic. Again, all 3, 4, 5 days. There is an important message here I want to convey, that we're not going to solve this problem by pointing fingers. Each one of us is in somebody else's backyard. So, as you know, in the current global warming debate, the developed nations, particularly US, we were telling India and China, unless you join us, we're not going to sign. And India and China in return, they say, I was in a meeting 4 months ago when this exchange happened between leaders. India and China says, you caused this, you fix it, give us a chance to pollute. So, and this is the case when, Mahatma Gandhi said, is a freedom fighter of India 50 years ago, an eye for an eye is going to make the whole world blind. And unfortunately, the global warming is the case. That's probably could happen or will happen, okay? So this is where we've got to put our heads together and solve this problem together. So let's see what happens. So we have this thing traveling fast and surrounding the planet, like a blanket. Do we see evidence for this? This thing is the most famous curve, icon of global warming debate. And I'm proud to say this was created by my distinguished colleague. He passed away a few years ago, Dave Keeling. Made measurements on top of Mauna Loa in Hawaii, and you see how the carbon dioxide is increasing steadily and more rapidly, okay? And in terms of the sheer weight of it, how much have we put? Every year, we put out 8.5 billion tons of carbon dioxide in terms of carbon, okay? Just in the sheer weight, that's equivalent to having 4 billion Toyotas, which is what I have, zipping up in the air. And we've been doing this for the last 100 years, steadily increasing. There's over 200 billion tons of carbon in the air, which we have added. Okay, the sheer weight of it is staggering. Anyway, so think of it as surrounding the planet like a blanket. So I'm going to take about 30 seconds to condense my course on climate change into it extends over a quarter. I'm teaching it now. So the fundamental energy source of the planet is sunlight. Not all of it we absorb, or 30% is bounced back. So the rest of it heats the planet, and so the planet gives off this heat as heat radiation. You call it infrared. That's how infrared cameras work, or heat radiation. So, and this is what has been happening. So this happens till what goes out is balanced by what comes in. And it's that balance we are upset by increasing the thickness of this blanket, okay? So the best metaphor I can think is, think of in a cold winter night, you cover yourself with a wool blanket. Why? And it keeps you warm, not because the blanket gives off any heat, it traps your body heat. Okay, so you're not cooling as fast, and so you get warm. That's exactly how these greenhouse gases work. They trap the heat coming off from the planet. And this has been measured. This has been one of my work for the first 15 years of a distant past when I was young. And I'll show you how we measured it. And so we know this. And what governs this heat trapping, this basic quantum mechanics. So I know you hear a lot of my colleagues, when they talk in public, they dumb down the science so much that it becomes speculative. It's not. It's been measured in the laboratory, how these gases absorb, and I'll show you how much it has absorbed, okay? So we used to think, this whole thing was first started, the science of this global warming and CO2 was started by a famous Swede, Svante Arrhenius. He was a father of physical chemistry and he got his Nobel Prize for that. And there's been work on this for nearly 70 years, and they used to think, there was a report published in 1971, the Swedish Academy of Sciences and MIT, which concluded, yes, it's a problem, but mainly it's carbon dioxide is the only gas known to us. And I was then an engineer in India, and I just didn't like engineering, came to the US to do something useful, and my advisor changed to atmospheric science. I shifted with him, and after I finished my PhD, and I found out this work by CFCs, with these two chemists who got Nobel Prize, suggested this chlorofluorocarbons, which is used as refrigerants, was destroying the ozone layer. Just out of curiosity, that's how science is done, I started looking, do these gases also have greenhouse effect? And to my utter surprise, and my wife knows this, I was a postdoc then, I sort of discovered this with simple calculations. I waited for 3 to 4 months, repeating it. Turned out what I came to the conclusion is CFCs, each molecule of chlorofluorocarbon has the same greenhouse effect as adding 10,000 molecules of CO2. So CFC is a synthetic molecule. Here it's a human being. We have invented the super greenhouse gas. And later I'll conclude with that. It has an implication for how to make Mars habitable. There was a science fiction written after this paper, okay? Quickly the list grew, and then suddenly there were over 10 and 20 different greenhouse gases we are putting on the planet. And the United Nations commissioned a report. They asked me to chair it. This was in '83. And we released a report in '85 in which we showed the non-CO2 trace gases are contributing as much as carbon dioxide. So suddenly the problem has become twice as urgent. So I got curious into thinking, when are we going to see this warming? So there are two issues, how large and how soon, okay? And when we published these reports on the CFC, the community at large was skeptic. In fact, there was academics in Ivy League schools, I'm not going to name them, they all proved to be wrong. They said this work is rubbish, and it's wrong, it's dangerous. And it took nearly 15 years, this group of what's called Intergovernmental Panel on Climate Change. This is the group the United Nations organized in 1998, which won its Nobel Prize in 2007. And they basically confirmed our findings in 2001. And I don't want to bore you with the details. What you see on the top is the thickness of the blanket. Okay, first you see carbon dioxide. And then you see next methane, comes from cattle, fertilizers, nitrous oxide, fertilizers. It has got big implication to the biofuels. I'll talk about that. Halocarbon, these are replacement for refrigerants, okay? And then ozone. We think of ozone, tropospheric ozone in the lower atmosphere as a pollutant, but it's a major greenhouse gas. This is something me and my colleagues pointed out 25 years ago. So when you add these other gases, although each one of them is nickels and dimes, they add up to as much as the carbon dioxide. There is a bad news here, but the good news is they offer opportunities to cut down the global warming, which is sort of being missed. We are still focusing this as a CO2 problem. Okay, I'll comment on that. So the question is, I was after to see how thick are we making this blanket? Nature gave us a greenhouse blanket, water vapor, various gases. So you see here on the satellite, and we designed, I was one of the main PIs, it was a NASA experiment. We launched scanning telescopes with radiometers measuring the heat coming from the planet. What we discovered from that, on the right-hand side, the unit is watts per square meter. Watt is the same as the watt we use when you say 60-watt light bulb. Square meter is square meter of the Earth's surface. And the nature's blanket is 130. So we have made the blanket thicker by 2.5%. So that was the metric we have. I wanted to understand, put the context of this, okay? So that's a substantial change we have made. And that number, by the way, and the 2.5% is not part of the controversy. That's sort of incontrovertible, within a plus or minus 15, 20%. So my own approach to the climate change, most of the things you see is from models. And since I started life as an engineer, unless I can touch and feel and see it, I don't believe it, okay? So this is something you can see, you can measure it. So what does that 2.5% mean? So in terms of terawatts, our global energy consumption today is 13 terawatts. Tera is 10 to the power 12, 1,000 billion. But compare that with the energy trapped by the greenhouse blanket, it's 1,500 terawatts. So the thing we should think about is, why has the planet not warmed tremendously? It's 100 times more than the energy we consumed, okay? So we got curious to see how large and how soon. And so this was a paper published in 1980. I'm showing this for two important reasons. For most of you, you started hearing about the climate change probably after Al Gore's movie, The Inconvenient Truth, and the media coverage. But scientists have been talking about this for the last 30, 40 years. And see how I start my paper. We say the possible climate effects of large increase in atmospheric CO2 constitute one of the important environment problem of the coming decades. If I were to write a paper today, I would still start it the same way, okay? And there was a huge statistical study looking at the variability and models, and what we concluded was, on the bottom one is, say, we should see this warming by the year 2000. The first statement was made by other colleagues, just not by us. All I'm saying is, as scientists, few of us working, we knew it's going to be a serious problem. We were a little bit too timid to talk about it because we thought nature was so complex that there is a way out there. It's going to find a way to compensate all this. Okay? Anyway, we made this forecast that we are going to see the year 2000. Of course, I was severely criticized for making such a forecast. And now the same Intergovernmental Climate Change on 2001, they concluded that there is a discernible impact of human beings, and then 2007 concluded it's an unequivocal warming, and we see the temperature record. These are basically thermometers held around the planet, or the ships, in the land stations, and over the last 140 years, and you see things, there are hiccups. It goes up, it comes down, but the last 30 years, the warming has risen far above the noise, okay? And you can see how the trend is accelerating. So that's what concerns us, okay? So two of the forecasts, unfortunately, has come true. And so I got interested. This is a study I made 25 years ago, but I didn't publish it. I was waiting for more data to be collected. And we published in 2008, how large, okay? What we concluded was that we have put enough greenhouse gases on the planet to warm the planet by almost 2.5 degrees. Okay, I'll tell you why that's such a big deal. But unfortunately, the climate system is so nonlinear, I can't really tell precisely what it is. So all I can say is a statistical probability distribution. So there is a 10% chance the warming could be much smaller, factor of 2 smaller, maybe less than about a degree. But there is a just as equal a 10% chance the warming could be larger than 4 degrees Celsius, okay? If it is less than a degree and a half, that's the best thing that can happen to all of us, except for me. You will stop inviting me as dinner speaker. But on the other hand, if it is greater than 4 degrees, almost everyone in the community will agree that would be a disastrous change. And I show here what are the iconic changes you will see. So somewhere between 1 to 1.5 to 2 degrees, the Arctic summer ice would disappear, okay? And that's got huge ecological impacts. People think of the summer ice, okay, the polar bears are going to disappear, which is, of course, would be sad. But there's a lot more than that. I'll talk to you about that. Because the summer sea ice, because it's so white, it acts like an umbrella, shielding the planet from intense sunlight. Okay, the snow is white because it reflects 80% of the sunlight. You blow off the snow, the ocean underneath is dark. It absorbs 80% of the sunlight. So there's going to be huge, massive heating of the Arctic region. Okay. Next comes the Himalayan Tibetan glaciers. I'm personally working on this problem. Of course, I'm originally Indian. Now I'm an American citizen. But varieties of reason, not only that, the reason I'm focusing on that is the Himalayan Tibetan glaciers provide the headwaters for all the major rivers in Asia. The Indus for Pakistan, the Ganges for India, and the Brahmaputra for a lot of the India and the mountain states, and then the Mekong from Vietnam and the Yangtze from China. There are over 2 billion dependent on these rivers. And the sad thing is, when I talked about this 5 years ago, the Indian government and others were very skeptical because the rivers are flowing good. So when the glacier is retreating, the river is going to be full. But there is a calculation which shows after 50% is gone, then they will start drying out. And then the Greenland ice sheet, as you know, if that were to disappear, fortunately the time scale for that is 500 years or so, whereas the Himalayan Tibetan glaciers, you're talking about 10, 20, 30 years. The Greenland ice sheet, of course, would re-rise sea level by about 20, 25 feet. Okay, so on, and then the rainforest is supposed to go away by the time the planet warms 3 degrees, and so on and so forth. And these will look like science fiction. But the distressing thing is, it's not in the future. We already put enough gases. The intriguing thing is, if you see the observed warming, it's only 1/3 of that. What we have seen so far is only 1/3 of this 2.5 degree warming. And in spite of that, I decided to make that forecast, and I want to walk you through this. What happened to the remaining warming? Okay, there is, what I point out, we have made a Faustian bargain. So I thought this is about the time when I give dinner talk, people go to sleep, so I need to wake up people. So, and bring back your blanket, right? So nature gave you a blanket which keeps you warm. You made the blanket thicker, which is it should have made you a lot warmer, but you're not feeling it. Why is that? It turns out, as we were putting these gases, like I showed you in the smokestacks, we're also putting particulates. Okay, these are acids or solid particles. Some of them reflect sunlight. So go back to your blanket, you put mirrors on the blanket, and the mirror has reflected the sunlight and acted like a mask. I'm using the word mask for a deliberate reason, because we are in the process of unmasking it, okay? So we have not yet seen the true nature of the greenhouse beast. So how did I come to this conclusion? First of all, I call these particulates as brown clouds. Why is that? This is a picture I took of Los Angeles not too long ago, but for 2002 Christmas time. I was just flying in from Hawaii, and we see this. And we used to think of these brown clouds as just an urban phenomenon. Like I showed you, now we have discovered what starts off as an urban phenomenon because of fast transport becomes an intercontinental source of pollution. So to find out the nature of this mask, we did an experiment in the Indian Ocean. It started out as a small experiment between myself and Professor Paul Crutzen. He got his Nobel Prize for his work on ozone. It became a huge international experiment. Many European nations were involved. India was involved in a big way. So what we did was that the northern Indian Ocean is subject to pollution from India. The southern Indian Ocean was pristine Antarctic air. So if we take our aircraft and ships go north-south, we should be able to see what's going on. But nothing prepared us to what we saw. And on the top, as you see the brown clouds, that's what we saw over the entire Arabian Sea and Bay of Bengal. Vast areas of ocean covered by these dense brown clouds. And on the bottom is what we collected as filters from C-130 aircraft. And on the, on the thing below the photograph, what you see is the particulates we collected just coming off India, about 500 kilometers off of Bombay. And those ugly little particles you see are soot, the black stuff you see coming off diesel and fire burning. And to see what nature produced, we had to go almost to Diego Garcia. That's about 3,000 kilometers. We have to go south 3,000 kilometers to escape human impact. And on the bottom left-hand side, you see the particles nature emits. This is sea salt. So we caught them red-handed. And then we had instruments which measure sunlight directly. I'm not going to go through all the details. What we did was, we took the ship, went in and out of the plume. And if you follow the direct pristine and direct polluted, we were shocked to see almost 30% of the sunlight was blocked. And same thing would happen on Los Angeles when you see thick, dense brown cloud, as much as 15 to 20%. So these particulates were enormously efficient in cutting sunlight, blocking sunlight. And that's not yet the surprise. And we thought that blocking of the sunlight was because of the mirrors reflecting. What we found was, in addition to the mirrors, which is shown on the other side, chemical sampling, sulfates, nitrate, ammonia, there was also this dark stuff, black carbon, that was absorbing sunlight, okay? So instead of reflecting it, they said, think of this black carbon as dust inside your blanket, heating your blanket, making your blanket electric blanket. Okay, so there are three things happening. The blanket thickening from the greenhouse gases, and we are putting mirrors to reflect sunlight, but we also put dust in the blanket in terms of soot, which is heating. Okay? Pretty complex stuff. So we then took all of this, combined it with ground measurements, aircraft, and satellite. On the top, you see the blanket where it's someplace thicker, the greenhouse gas is uniform. Okay, you see over China and India, massive thick blanket, the dust, the black carbon absorbing sunlight, heating the air. On the bottom, you see the reduction of sunlight to your body. It's dimming. So if you have this blanket over your eyes and say the mirrors, you will find things are getting dark because the sunlight is decreasing. You think, oh, so I'm going to cool. It turns out some of that is heating the blanket, making your blanket hotter. Anyway, when we added up all this, what we found, the atmospheric brown clouds have, cooled, called the reduction of heating by about 1.5. Remember, the greenhouse forcing was 3. So 50% of the greenhouse warming has been masked by these particulates. So you would think, oh, so that's good news. The problem with that is, we know this is air pollution, it's causing acid rain, it's causing health impacts. We are getting rid of them. We are unmasking it. Particularly Western Europe has been so successful. They are recording some of the largest warming. Just in the last 6 months, there have been 6 papers published. When we published this in 2005, of course, that's become now practice for me. Whenever I publish anything, immediately there's disbelief. So I know I'm right by the number of papers which say I'm wrong. If nobody pays attention to it, then I start worrying. And now it's pretty well accepted. The reason for the rapid warming is because of the unmasking. The problem with this is that while the unmasking is happening in Europe to a large extent, US a little bit too, we are adding this mask over India and China. Okay? As you know, you're all technologists. The initial part of your growth, your industry is polluting industry. Then you get wealthy, you start cleaning up. Okay? The problem with that is in India and China, the dust, black dust, is more than sulfur. Chinese put a lot of sulfur, but India puts a lot of black carbon, heating. So And then, of course, IPCC 2007 came, and the cooling things are shown. Their estimate is within 10% of what we said it is. So there is some sort of agreement. Yes, we have masked about half of the global warming, which means there is price to pay when you unmask it, okay? Then you would think, okay, this pollution is good, it's causing cooling, but there is problem regionally. One of the dumbest thing we can do is cut sunlight off. That's what we are doing. Or India, the sunlight is less by 7%. Or China, it's about 9%. And we have used measurements over the US and Europe, it was less by 10% 30 years ago, okay? The problem in cutting sunlight is, what is your source of rain? You know, you all read in our 6th grade textbooks. I didn't read it in India, they didn't teach me, but I found from my kids' textbooks here. So-called water cycle. Where is the water coming from? Sunlight hits the ocean, and the energy is used to evaporate water from the ocean. It's pushed towards the land and falls as rain, okay? So you cut the sunlight going to the ocean, you're going to cut the evaporation. It's simple, basic physics. And you cut evaporation from the ocean, you have to cut rainfall. And we see that, I'm showing here the Sahelian drought, which wiped out about 1 million sub-Saharan Africans in the 70s and 80s. It's blamed on sulfate pollution from Europe and North America during the 50s and 60s. And we have been working on the drying out of the Indo-Gangetic plains, the red spots you see in North India. Of course, when we published it in 2005, Indian scientists and the ministry were skeptical, and they, in fact, even suggested I'm paid by the oil industry, and President Bush was telling me what to do to turn attention from global warming towards India. And I remember in a meeting, I said I'd be so honored if my president would ask me what to do. And you see in northern India, the drought off of Beijing, main worry of the Chinese is the desert is going to take over Beijing. And so the planet is drying out in the tropics, and that's what you expect from particulates. Global warming should increase precipitation. We are not seeing that. In the extratropics, we are seeing increase in precipitation. The other major story is that it's all coming out last 5-10 years. The black carbon heats the air. Remember I said make the blanket warmer. So you heat the air rises and heats the Himalayan region. The second thing is the particulates, the black carbon ultimately is washed out by rain. We have made measurements, and when they fall on the snow, they make the snow dirty. When you make the snow dirty, it absorbs more sunlight, it melts the snow. And we found that happening in the Himalayan region. And the way we found that, using this unmanned aircraft, and Professor Smar has kindly agreed us to, we're going to show this aircraft and how we did the measurements in the display on Thursday. For the first time, this technology was developed by the military, but even they had not attempted to do what we did, fly this aircraft stacked. You can't do this simply by manned aircraft because they have to be exactly on top of each other. So we captured the brown cloud in between the 3 aircraft and found out the enormous heating going on from black carbon. Unfortunately, NASA at the same time launched a satellite with a laser instrument. On the top you see, as we were flying over the Arabian Sea, the satellite was going by us, and the satellite showed the Himalayan region is surrounded by these brown clouds, black carbon, okay, both from the China side, the India side. And this is a site, I'm chair of this atmospheric brown cloud project from UNEP. This site, you see the data on the bottom one, is done at the base camp of Mount Everest, the highest air pollution station on this planet, okay, 5.5 kilometers. And we are measuring black carbon as much as what we would see in downtown Los Angeles. This is close to Mount Everest, okay? So there is clear proof. And on the top, I'm showing the glaciers retreating. The top left-hand one is the glacier which feeds Ganges, and the right one is Bhutan. The problem with the melting is that it forms glacial lakes. And if the melting is too rapid, the lakes break down and causes floods. It's called GLOF, GLOFs. On the left-hand side, you see the Arctic sea ice, how it has retreated from 79 to 2003. We just won permission, from NSF to fly our UAVs in the Arctic to see how much is from black carbon. So I need to give a sort of a cautionary warning to this audience. If you are polluting, I'm there measuring your pollution everywhere, from glaciers to the Arctic. Okay, but you can see the disastrous retreat of the Arctic. And you can see right there, you don't need me as a scientist to tell me, when the sea ice is gone, you expose the blue ocean. It's absorbing all the sunlight. That whole region is going to heat up. It's already heating up. The warming over the Arctic is 2 to 3 times the warming from global average. Okay? So now, enough of the bad news. So the question is, first I want to, what are we doing to avoid a disaster? And I'm so happy that USA is back on the saddle in mitigating global warming. We heard the most exciting news today about EPA trying to improve the efficiency of our cars, mileage-wise. Hopefully we'll cut down our CO2 emission from automobiles by 30%. But it's not enough, okay? And I feel, I was in Sweden 2 weeks ago, was talking with the Swedish negotiator as well as the EU negotiator, and then I was in meetings. My opinion, you can think of personal, the negotiations are focusing on what could be done and not on what should be done, okay? So, and my feeling is that contemplated actions cannot hedge against large catastrophic changes, okay? Nor against sudden climate change. We are expecting a linear change, and we know that system is never linear. So if there is any flaw in what I talked about, we are always thinking linearly, but the change could happen suddenly, okay? So see what's happened. Why am I saying the international negotiations are not enough? The 2007 carbon emission is about 8.5 gigatons per year. So the fixed emission, that if we don't do anything and also we don't increase it, which is also unlikely, by 2030 we would add 108 billion tons of carbon as carbon dioxide. If we reduce the emission by 50% by 2030, as our President Obama wants and the international negotiations, we will still be adding 80 gigatons. What's going on? Simply that whatever CO2 my wife and I drove, I don't drive anymore. My wife, I let her commit the sin for the family. She drove. So the carbon dioxide, if somebody put a flag on all the molecules we emitted, about 55% of the CO2 molecules would still be circling by year 2200. Okay? And about 20% would be circling year 3000, 1,000 years from now. Because that's the sad thing about CO2, its lifetime is too darn long. It stays there forever. So even though you cut down the emission by 50%, you're still adding the other 4.5 gigatons. That's accumulating, okay? So these discussions are not going to stop the committed warming. They will reduce the rate at which you committed warming. And if you doubt what I say, look at the emissions on the left-hand side. It's 3 times as much as what it was in the 1990s, and you see the CO2 increasing. That's one. The second thing is that I'm basically saying this so-called dangerous climate change is in our rear view mirror, and we are driving fast. Okay, one is increasing CO2. The second thing is, remember I said the mirrors as what we made a Faustian bargain are saving us? We are going gung-ho about reducing those mirrors. One thing we are reducing rapidly is sulfur dioxide. We should, I'm not saying keep polluting the planet, but the thing is, when you cut down SO2, the urgency to cut down CO2 increases. You've got to do something to compensate. So we are leaving the dust in the blanket. I'd say electric heating the blanket. We are removing the mirrors, and we are making the blanket thicker. So that's what I mean. We are driving towards the cliff. The only thing I don't know is how far the cliff. Is it 10 years around the corner? Is it 100 years around the corner? I don't know. So what I propose, first of all, so if the year 2050, if we continue business as usual, we would have increased the warming commitment from 2.4 to greater than 3 degrees. And anyone in the climate business will tell you that's pushing the system, okay, beyond or towards the tipping point. Now, the other thing we can't forget is the population is even, will increase to about 8 billion. Many are predicting 9 billion. So how are we going to feed all of them? And let's say that we have $2,000 nano cars or $1,000 nano car. So, so what I suggest is that we need to think about a two-tier approach. First, we need to think about reducing future commitment. We've already committed 2.5. At least we have to make sure that we're not committing it anymore. So-called avoiding the unmanageable. That term I took from the UN document. So the only way we can do that is reduce fossil fuel consumption, at least by 80% by 2050. Okay, how we do that, I'm not going to touch on it. There's a vast cottage industry talking about solar, wind, carbon capture, et cetera, et cetera. The one I'm focusing on is I'm more focused on hedging against abrupt and large changes in the next 10, 20, 30, 40, 50 years. I'm focused on how can I reduce the committed warming, the 2.5 degrees, bring it down to about 1.5 degrees. And the second, of course, is manage the unavoidable, which is the adaptation. I mean, clearly, climate change is happening. It's going to get worse. We got to figure out a way to adapt to it, okay? But I'm going to focus on how to reduce the committed warming. Fortunately, black carbon, ozone, are all short-lived substances. What do I mean by that? If we cut down the emission, their lifetime is a week to 10 days. You already know that. When there is rainfall, the sky looks blue. Why? It just washed out the pollution, right? So if we cut down the emission by 50%, their effect will go down by 50% immediately, within few weeks. And our current estimate is the black carbon is contributing somewhere between 20%. This is the IPCC. My own estimate is close to 50% as warming compared to CO2. Ozone is another 20%. This is the methane. Methane lifetime is 10, 15 years, another 20%. So you got 60% here. That will buy us about 20 to 30 years to figure out the carbon dioxide mess. Now, it's clear to everyone, you need revolutionary technology. And even if the technology was invented tomorrow, it's going to take 20 years to penetrate the market. Unless you work it to India and China, it's not going to have much of an impact. So we need to buy the time planet 20, 30 years. So I talked about this, and it's clear that I need to do it myself to show it. Okay? So we started this project called Surya. In Sanskrit, Surya means sun. And I want to tell you what we are focusing on. It turns out, in India, 2/3 of the black carbon is due to my grandmother. Okay? So you see that the firewood cooking is the major source of cooking. So we did a simulation teaming up with a chemist, outstanding chemist from University of Iowa, and we did a what-if scenario that we persuade all my grandmothers in India to switch from cooking with cow dung and fire to biogas plants, solar cookers, and energy efficient, same cookers emit a lot less, and the black carbon is almost gone. It's almost looked like, think of your windshield in your car, dusty, and you just took a wet cloth and wiped it, it's gone. And if we are to switch the cooking, fortunately, this is one area we know how to do. We know how to cook without producing smoke. So we want to show this by demonstration. So we are taking two regions, one in the densely populated Indo-Gangetic plains in North India, population of about 15,000, okay? And one in the Himalayan region, in the valley region, and switch the cooking. And one of the local benefits of that is 500,000 deaths in India is due to inhalation of the smoke. So there's tremendous incentive on the part of women and children to want to do that. They're not stupid. They just have no other access. Their total salary is $2 a day. And I spent so much time in the last 2 months in villages, and they told me that their biggest thing is, look at that kitchen. Half the kitchen is occupied by fuel. Why do they have to put it inside? Again, they're not stupid. It's raining outside. So she said, to me, to get more space in my kitchen alone is worth it for me. Okay? And so we started this now in a small region, in a village. And you see that this is on the left-hand side. This had just happened about 5 weeks ago. And you see this woman on the right-hand side proudly touching the cooker. That's been burning for almost 45 minutes. It's such a remarkably designed system. It doesn't let any heat escape. In the traditional mud cooking, mud stove, 65% of the heat escapes. So although she's still burning wood, she's burning factor of 2 less wood to prepare the same food. And the second source of indoor pollution of black carbon is kerosene lamps. So we are providing them solar lamps. That solar lamp is $8. Okay, we charge it during the daytime. And the other thing is that girls drop out because they don't have lighting to do homework. So the boys get the first chance to do the homework. And our kerosene lamp, we can have only 2 people surrounding it. So this is going to hopefully revolutionize education. But we are not, although it's contributing to development, our interest is to gather the data to find out how much global warming is it going to save. Okay? So of course, I think Mr. Anderson already talked about that. Fortunately, it was covered by time, so that attracted some donors. But the key thing is, it's taking most advanced technology to the most primitive conditions. So we're going to surround this village, these observational towers. NASA has agreed to give me high-resolution data to follow this village, this rural area. Basically, I'm going to create a black carbon hole. Okay? And I'm hoping that I'll be able to show the villagers the data they can see. That will provide them the best incentive to continue this. Okay? And the thing which we are hoping is going to revolutionize, which is very important to this, is the data collection. I need to collect vast amount of data in every home if possible. So we're going to employ mobile phones, okay, and instrument them. And this is led by a group at UCLA. You can see from the name. The first author is my daughter, who's been working on this problem pro bono for the last 2 years. And the way we are going to do that is we will have these filters with a micro pump, run the indoor polluted air through the pump, and it will color the filter, and the filter will be captured by cell phones, photographs, and then download into data, and we'll calibrate that. Okay? There are many other ways. I'm just giving you one example of it. Our hope is we will do it on home-by-home basis in a vast number of homes, and use sophisticated computing so that we can map out this for a large region. After all, there are 4 billion cell phones. It's an enormous data collection for environment. One thing we are starved in the environment is data, good data. And the other question I'm asked is, what is the business plan we have? We have talked with the Chicago Climate Exchange Commission. They have agreed to give carbon credits to the villagers. It turns out the rough estimate is each villager would get about 28 cents a day if I can show with my data that they've cut down the black carbon emission. For us, 28 cents a day is nothing. It's not even going to buy a Coke, but the villager's salary is about $1 to $2. For them, it's a 20% increase in the salary. And I normally say, if somebody will increase my salary by 20%, I'll cook with anything. So to those who ask me what's the incentive, that's where the climate game has changed this fundamental development obstacle India and China faced. Indian government wants to switch the cooking, but they haven't found a way to do it. So hopefully, our hope is that we collect the data, take it to United Nations, take it to American government, and try to make it into a global policy. Okay, something we should be doing in any case. The last thing I want to say is that I have come to the conclusion, seeing all the things going on, each one of us need to have a personal reason we want to do this. We have to do it. We need a personal reason. And my personal reason is here. That's my 1-year-old granddaughter. I'm smiling because I think I'm going to be able to contribute to the solution. She is skeptical. She thinks I'm going to pass the buck to her. Okay? Let me finish on one last note. This is more targeting the skeptics, I honestly don't think the skeptics are bad or the science. We have to question, okay? So let's contrast our neighbor planets. Earth is in the middle, Venus is closer to the sun, and Venus receives twice as much sunlight. So when you ask people, why is Venus so hot? As you know, Venus is so hot, you can just fry an egg on its surface. You don't need any electricity or any heat. So why did it get so hot? The skeptics say, oh, they got so hot because it's closer to the sun. It turns out Venus is the brightest object. Reason is it's completely covered with clouds. So it reflects 70%. The sunlight absorbed by Venus is about 10% less, 20% less than what's hitting the Earth. Okay, you see that Venus is absorbing only 200. So why is Venus so hot? Because it has 100,000 times more CO2. It is a carbon dioxide greenhouse effect which ran away. Okay, so we know greenhouse gases can run away a planet heat. Look at Mars on the other side. Its blanket is too thin. It's so cold that everything's froze, even carbon dioxide. And the science fiction paper was written after my paper on CFCs. His proposal was, this was written 25 years ago. He said, we are going to mess up planet Earth. It's going to be uninhabitable. So what we need to do is to pump up the CFCs to Mars. So the greenhouse effect of CFC would heat Mars to let loose its ice caps. I hope we don't have to do that. Thank you. Yeah, I think if you read the papers written even in mid 1990s to late 1990s, no one was even thinking about or even thought things like Greenland ice sheet or West Antarctic ice sheet would start melting. And we had rude awakening. There was a new satellite, gravity satellite, launched, and it had precise measurements of mass, and that showed Greenland ice sheet is losing its mass. And the disturbing thing about that losing its mass is we were thinking, oh, you heat the air, so it'll gradually melt, and that's what 3 kilometers thick. And now the finding is it's melting not from the top. The ocean is getting warmer, so it's melting in the bottom. So just imagine a massive ice sheet and you melt the bottom, it's sitting on rollers. Vast amounts of icebergs and ice sheets could slip into the ocean. And they're just, as you said, beginning to see similar things happening in the West Antarctic ice sheet. The East Antarctic ice sheet is so massive, we're thinking, thank goodness, nothing we do is going to do anything to it. But the West Antarctic ice sheet is a different story. And they're seeing carving there, and they're seeing melting in that. But that's all just recent, last few years. And we have to be careful also. Is I try not to get excited about these things, what happens in the last few years, because nature has huge variability. We know 1 year weather is never the same as next year. One winter is warm, another is cold. What people like me working in the climate field, we start believing things if we see something happening over a period of 10, 20 years. Sustained changes, then we know there is some long-term thing going on. So whereas Greenland is slowly becoming, unfortunately, a long-term change over 8, 10 years. It's losing mass. Now, of course, if the West Antarctic ice sheet melts, it's I would say, unimaginable disaster in terms of sea level and all kinds of things.
I guess listening to some of the skeptics, I hear this argument that they say, while it's true that over the last 10 years or so, the Earth has gotten warmer as a trend, but also Mars and... Should I repeat it? I guess listening to some of the skeptics, you hear the Republican Party going and talking against President Obama's, I guess, new measures taken today. They're talking about while they agree that the Earth has gotten warmer over the last decade, but the arguments I was hearing from them quoting some scientists is that the Mars and Venus have also gotten over the same period warmer, and there are no human beings or, I guess, people polluting over there, and therefore these cannot be man-made. So can you tell us some of that? So next time I hear that argument, I would have some scientific.
Good point. First, let me start with Venus. My graduate thesis was on Venus and Mars, so I know a little bit about it. Venus, its atmosphere, the bulk of the Earth's atmosphere is about 8 kilometers, maybe 10. Venus is 60, and it's completely covered with clouds, and most of the clouds is sulfuric acid clouds. And no known instrument can penetrate to the surface. So if somebody can tell me how Venus surface temperature has changed over the last 10, 20 years, that will be a remarkable discovery and finding. We have not been able to penetrate the cloud top, is at 55 kilometers. The only thing which penetrated that was the actual probe, which almost went to the Soviet probe, and then US sent its probe. And I was a graduate student then. Mars, it could have temperature change, because Mars, what happens is that depending on the weather, it has huge dust storms. And the dust storms, would last, cover the whole planet. Okay, and that changes the distribution of sunlight going into the surface. It could change temperature, but I don't know how much it has changed. But I don't understand how we can ask the argument, just because something is changing, ours changing is also not due to human activities. See, that's how we predicted that the warming we'll see by year 2000. We had a 150-year record. So we quantified how much Mother Nature varies by itself, and then compared the signals, what standard engineers do, signal to noise. So, and the skeptics also said, oh, most of the changes was coming from sunlight. On the satellite I worked, we launched the most sophisticated solar measurement, and then it was followed, and we quantified that. It turned out the maximum we can explain is 0.2 degrees. The observed warming is about 0.8. And none of these explanations, they've been able to explain the observed warming of the last 35 years, except the models which include the greenhouse gases. So that does not necessarily prove that nature could not have caused it, but the skeptics have not shown it, except hand waving in hearings. So there's no paper we know of where they have shown quantitatively what it did. They're just hand waving. But I have to be careful. Remember, I pointed out there is a 10% probability the human-induced warming could be much smaller. But that's all we have. There is a 50% probability that the warming is mainly due to human activities. And there is a 25% probability it could be much larger. So I think the question I would ask is, if you're a good citizen, we are talking about hedging against risks. If the skeptics turn out to be right, we'll all be happy. But if they are wrong, there are billions who are going to be miserable. So that's the issue. It's a complex system. And are you going to put your bets with about 2,000 scientists who have worked on this the last 20 years, and I've said we haven't found any other way to explain it other than human activities.
We're taking alternate sides of the room, one question at a time with the roving mics.
My name is Bright Simmons from Ghana. Professor, I found your theory about why we are seeing a delay in the warming very intriguing. If I understand it correctly, you're saying that we have a coating, a film coating of sulfates on the blanket cover. Now this is reflecting the sunlight back and therefore giving us a gap, a time gap, before which the full effects of global warming will be felt. Mine is a basic physical question. What then happens to the light that is being reflected from the ice caps back towards the atmosphere? Do we see a reverse effect where the same sulfates cover is also then reflecting that light back? Because that would then complicate the model, wouldn't it?
So I want to make sure I understood your question. So you're talking about what I said about this mask, sulfates reflecting sunlight, and your question was, what happens to the sunlight reflected by ice sheets? Is that correct, or did I get that? Yeah. When the sulfate is over the ice sheet itself is reflecting so much sunlight, the sulfate effect is very small, if not pretty negligible. So where the sulfate has the maximum effect in terms of masking is when it's over the oceans and clear lands where the reflection is low. Okay? That's one. As far as the sunlight reflected by the ice sheets, that's been happening over 1,000, 10,000. The Earth has adjusted to that. Remember I said only 30% of the sunlight is reflected back to space, and some of that is coming from the ice sheets. And now if we melt those ice sheets, talking about the sea ice, you are reducing that reflection. Or basically think of it, let's go back to the blanket. Nature has given mirrors on the blanket. Those mirrors are clouds, ice sheets, sea ice. So when you melt this and poke a hole, enormous amount of sunlight is going through and heating the planet. Okay? So both in the case of sea ice, if you assume that sea ice retreat is happening from global warming and black carbon, and that retreating is adding sunlight, and then we as human beings cutting down the sulfate is also adding sunlight. They're all working together. And the black carbon is also working together. And my own work suggests that's the reason why you see this major retreat, whereas the community thinks is mainly coming from greenhouse warming. I think it's multiple stresses on the system. It's not one thing. It's many things working in the same direction. I see some hand back. Yeah.
I'll just ask a question. Can you hear me correct?
Mm-hmm.
So I have a hypothetical question. If you had $100 million to gamble with, and you have basically two kinds of businesses to bet on. Social engineering businesses where you're betting on the idea that people will change their behavior. So you gave an example of that earlier of people changing what they cook with to something else. Or innovation businesses that gamble on technology breakthroughs which might either sequester carbon or mitigate heat. So you have the choice between those two classes of businesses, for instance. How would you gamble with $100 million?
First of all, I wouldn't think of any of this as gambling. These are all safe investments for the future. And the second is, first of all, I need to say, I'm a professor. I'm expert on converting a question into a question I can answer. Let me do that, and then I come back to your question. This low-hanging fruits I'm talking about, the cost of doing that, even on global scale, is at least an order of magnitude, if not more, less than the magnitude you need for technology to fix the carbon. We have to fix it. Just to give me one idea, we are putting right now 13 terawatts. We need energy, okay? There's one way to fix the problem is with nuclear power plants. But to pick up, let's say, even half of that 13 terawatts, you need to build a gigawatt nuclear plant every week for the next 30 years. So that's the magnitude of the problem we are talking about to fixing the CO2. So I don't think there's a comparison here. For example, my own estimate of converting, providing the cookers free to the 700 million rural population in India, it's about $1.5 billion to 2 billion. And these cookers have lifetime of 5 to 10 years. So whereas the DOE has estimated it's going to cost us somewhere between $30 to $50 trillion over the next 25 years to bring down the emission of CO2 by 50 to 60%. So there's just no comparison. But nevertheless, if you were to give me 100 million, I would take 50 million and do my cooking and give the other 50 million to some clever technologists.
Sorry, maybe one more question. Oh.
Yeah.
Yeah, Mark. Gary Rochelle.
Gary.
One more question is that, given that I live in Shanghai, so I'm one of the primary emitters for the carbon dioxide, I guess, that runs over the United States and the pollution these days. But if you think about the fact that today China, 72% of the electricity comes from coal, the most optimistic scenario by 2025 is that that'll be down to 64 to 65%. Aren't we really talking about a political problem and not a technology problem? You started to touch upon that in the last answer, but aren't we really talking about a question where we have to decide how do we inconvenience the least number of people, but that number is still going to be hundreds of millions in terms of actually solving this problem, because there really isn't a technical solution within the time frame that we need to worry about.
I didn't hear the first part of it. With the Mark,
He's
did you
talking
hear?
about how many coal plants there are coming online in China every week.
Mm-hmm.
And so who's being inconvenienced the most?
Yeah, I know that's a tricky question. The way I think about this, that's why I make the distinction between the committed warming and the future commitment. Okay, the committed warming is what's already up there, and I feel there we should take the lead, the developed nations. The increase to that committed warming is going to come mainly from India, China, and Africa. So we have to make sure that we reduce that future commitment. And we are certainly not going to reduce that future commitment by adding one coal-fired power plant every week. But we can do, if we think of it as a collective global commons, we can help the problem if we can provide the technology transfer to the developing nations to cut down their emissions of black carbon, ozone. These are all air pollutants. You see, the thing with CO2, we have to emit CO2 if you're going to use fossil fuel. There's nothing you can do. You can increase the efficiency, whereas we don't have to emit black carbon. We don't have to emit ozone. These are all coming from inefficiency. So my own approach would be to focus on the short-term warming agents, the low-hanging fruits, and then give the technology, say 10, 20 years of time to come with some revolutionary technology. I think many of my colleagues agree with me. We need another James Watt. We need a magic steam engine without coal. And I don't think it's unreasonable to expect that. The people working on solar, I personally don't believe the carbon capture people, because there are 200 billion tons of CO carbon. I mean, it looks mind-boggling to me. We're going to be able to take that. Where are we going to put it? But then I'm not an expert on this. But certainly, having worked with India at least, a little bit on the government and political level, the current approaches on both sides are not going to get us anywhere. India flat out says, it's not our problem. You created it, you solve it. But they know they're going to become a problem 10, 20 years from now. And they know they will be living in a world which should have become alerted to climate change, which would not allow it. So they know they have to face it. So everyone is just circling the wagons. So with China question, as you know, the Chinese emission of CO2 has already exceeded ours, and it's going to get worse. And for our own sake, we have to work with them. And I feel the only way it's going to happen is technology transfer.
Good, great. Thank you.